Hey there YouTube, Super Brain AK here. And what have I got here? Well, this is a board from a Poe phone, believe it or not. And well, what's cool about that? Well, it's got this power supply section which runs on Poe. What's that useful for? Well, it is a completely isolated switch mode power supply, and it runs off of a low-ish voltage, 48 volts. 48 volts comes in, and then it breaks it out into three different voltages. Let's see, like 3.35, and then some really high voltage, like 30 volts or something. But it goes to a tiny linear regulator down to 20. But yeah. So what I did is 3.3 is pretty low. 5 is okay, but still. How about 12? So what you might have seen in the last video of the live stream that I did is rewound this guy. Rewound the transformer in it. Obviously not this one. This one is a completely different one. But I figured I might show you on the paper here. Guess you can read that pretty good. Zoom in a little more. Just a little. Alright, so here are the windings here. These are the primary, I believe. And it's got 9 turns. I didn't actually count that, but that's the other half of the primary. And then it's got 18 turns for a feedback. And then on this side, it's got 20 turns, and then 2 turns, and then 5 turns. That's for the 3.3, and then it continues on for the 5, so it adds a total of 7 to get 5 volts. And then there's an added 20 to get that 30 or so volts. So I did a simple turns ratio. I know what the voltage was, and then I know how many turns, so it's about 0.7 volts per turn for the 5 volts, and then the 3.3 is about 0.66. So yeah, so I want to get 12 divided by however many turns I need, equals about 1.5. So I forget what that ended up to being, about 14 turns. So yeah. So the other thing is, sure, that'll give me ratio on the transformer correctly, but what about the feedback? Well, that's what this is right here. There's the optocoupler, there's the precision reference, and it was using the 5 volts and the 3.3 volts to get it. So all I did was I moved the 600 ohm resistor to here to replace that 330. That 330 is away, and then connected the 5 volts directly to here. Basically, it's on the power side, I'll show you in a minute. And then replace the 600 ohm resistor with, you can see my calculations here, we've got 3.3 times 10,000, because there's a 10K resistor there, making this a potential divider. That's ground. There's some capacitors and whatnot, and then a resistor for a snubber network. And anyway, so that's the pull down, there's the pull up. So it's 3.6K. So it's 3.3 volts times 10,000 divided by 3.6 thousand times plus 10,000. 3,300 over 13,600 equals 2.46 volts. So that's about the reference voltage. So 2.46, I want to get 12. I'll keep the 10,000 ohm resistor the same. So you have 12 times 10,000 divided by x plus 10,000, which is about, so you, oh, what did I do? Multiplied that over and then divided that over. So we've got 120,000 divided by 2.426 equals x plus 10,000. X plus 10,000 equals 49,454. And then just subtract 10,000 and you've got 39.5K. So, that's about the resistance that I need here in order to get the 12 volts on the output. So what I did is I added a 50K potentiometer. So we'll swing you over to the bench. Whoop, you zoomed in pretty far. If you can see that there, that blue guy, that's my potentiometer. My 50K potentiometer. And you can see it's just bodged in for a teeny tiny little resistor. And then I also remove the other two diodes. Oop. All good. There you go. So it's got a head of diode there and there. Those are removed. That one's for the 5 volts. So there still is 5 volts going on it. But that's with this little purple wire jumping from over here to over here. Ooh, these resistors are warm. And so yeah. You can see everything that I'm doing here. So we've got about 430 milliamps at 12.16 volts. And we can measure our input voltage coming in from PoE. That's tapped off here. 45.5 volts. See this gray cable. And let me get you close to it. Okay. There went a meter going off. So what have I got? This is an ISV. What's this? 4+2? Yeah, 4+2 PoE switch. It's got 4 PoE ports, which are 30 watts capable, and then 2 regular uplink whatever ports. And then, so this port is going up and around to my package devices W6, which is my access point, which is actually serving as a bridge right now to my jetpack, which is that guy over there, which I have added an antenna, which it does or doesn't work. I haven't quite confirmed that. So over here we've got that gray cable, and just like lit up with the PoE because, well, the Ethernet controller is not plugged in because I disconnected it. And then yeah, the switch goes on a 48 volt 60 watt power supply. So what is this good for? Well, it allows me to distribute 48 volts out to devices pretty easily, and it also allows me to isolate. So what I'm planning on using this one for, give me a second to put you on the tripod. So that should allow me to have an isolated power supply for this guy, which needs an isolated power supply in order to work properly. Because if I powered him from the same power supply that's powering him, or him, I will not be able to have the proper 4-wire sensing, since the grounds are all the same. And yeah, so I can't power a power supply from one of these and then use this as the load, unless I had a different power supply, which I do have now, but I kind of want to get rid of that. So the PoE should allow me to do that. Now, this guy is not made for very high wattage, since it cuts out pretty easily. But yeah, should be able to cut down the board to a reasonable size instead of this gigantic thing, and then have 12 volt out at 400, maybe 500. So I'll test the 150 watt load running off of it. But right now it's just running on those resistors and it's working pretty well. So that's the plan anyway. And also eventually, as soon as I get a battery system hooked up, quote unquote power wall, I'll be able to power the PoE switch from that, and that way it won't be reliant on the mains. So yeah, thanks for watching everybody. See you in the next video.